For the mass on the spring word problems, it's really important to read the problem carefully and draw a careful picture before you try to make the equation. So this problem is telling me that a mass on a spring oscillates at a frequency of 10 cycles per second. The spring is pulled down 25 centimeters and then released. We want to find an equation that gives the distance of the mass from its rest position as a function of time. So if I draw a picture of what's going on here, I have a spring. It's being pulled down 25 centimeters. I'm going to draw a middle line that represents where the spring used to be, and I'm pulling it down a distance of 25 centimeters. That means later the spring is going to bounce up and be at a height of 25 centimeters above the middle position. And then later the spring is going to bounce down to below 25 centimeters below the middle line, and it's going to repeat this, bouncing above and below the rest position. Okay, so here I start at the bottom, I go up to the top, down to the bottom, and complete this pattern to infinity. One, two, 3, 4, 5, 6, 7, 8, 9, 10. The question tells me that the graph completes 10 cycles in 1 second. Okay, so 10 cycles means the same thing as 10 waves. And this whole distance takes only 1 second. And it goes up 25 and down 25. So luckily I know some equations for frequency and period. Frequency is the same thing as the reciprocal of the period. So if I want to find the period, I can take the reciprocal of the frequency. So because the frequency is 10, the period must be 1 over 10. I also know that B is 2 pi over period. So, because period is 1 over 10, when I divide by a fraction, that's the same thing as multiplying by the reciprocal. So the value of B is 20 pi. Now I've got to figure out what my best basic graph is going to be. So my choices are cosine, sine, negative cosine, or negative sine. So the basic cosine starts at the top. The basic sine starts in the middle. The negative cosine takes the basic cosine and flips it over the x-axis. And the negative sine takes the basic sine and flips it over the x-axis. So because this graph starts on the bottom, it's pulled down and then released, my best choice for my basic graph is going to be the negative cosine. So I'm trying to make an equation that has negative as the first term. I'm trying to find values of B, C, D, and A so that this will make sense. So the amplitude is the height of the graph. This graph goes up 25 and down 25. So my value of the amplitude is 25. We calculated B. B is 20 pi. C is how much the graph moves left or right. So I'm going to take the bottom and see how far did the bottom move away from the y-axis. But in this case, it didn't move at all, so C is 0. And D is how much the graph moved up and down. So if my graph is really high, I take a look and see how much did the middle line move compared to the axis, and it turns out that this one didn't at all. And for all these graphs with spring questions, C and D can be 0. So my final answer is that y is 25 cos of 20 pi x. If I want to make sure that makes sense, I'll try to graph it. So I'll type in negative 25 cos 20 pi x. I'll zoom trig, but you can see that it's really hard to see. For one thing, it's going up 25 and down 25. So if I change my window so that it at least goes up 25 and down 25, maybe I'll go down 30 and up 30. Okay, it's still kind of hard to see. In fact, it looks like it wobbles a bit. So let me change my window again. I know that the frequency is 1 second, so I want to see what happens after 1 second. Maybe I'll go just from 0 to 1. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This graph finishes 10 cycles in 1 second. Now if I go from negative 1 to 1, you'll be able to see that this finishes 20 cycles in those 2 seconds. Super hard to see. So let me zoom in again. Maybe I'll just go from negative 0.5 to 0.5. I want to check and see that it starts in the right place. Okay, so I can see that this graph starts at the bottom, which is where it's supposed to start. Start at the bottom and then it's released. So this graph makes sense. Even though it took me a long time to find the window, it was a good way for me to check and make sure I had the right answer.